Thank you for viewing the Standfast Drives extended startup video. This video will provide startup instructions for a VACON 20 compact drive, as well as the VACON 20X and VACON 20 cold plate drives. Please take a moment now to pause the video to read the safety warnings shown here. Failure to follow these warnings could result in death or serious injury. Hi, I'm Stephen Floyd, a service trainer for Danfoss Drives. In this video, I'll be presenting the basic setup and functions of a VACON 20 series drive. I will mainly cover the standard VACON 20, but I'll also discuss the VACON 20X and 20 cold plate drives, as they have the same interface and similar setups. The video will consist of basic terminal connections and configurations, keypad and display functions, information on the startup wizard and quick setup parameters, and available software application choices. I will also demonstrate running the drive in local or keypad mode, as well as in input-output or I/O mode from the terminal strips. Here we have a standard VACON 20 compact drive. This is the most common type of 20 series drives, but I will discuss the 20X and 20 cold plate drives as well later in the presentation. The drive shown here is a frame size MI1. The MI2 through MI5 frame sizes are physically bigger, but the setup and access to the input-output or I/O terminals and dip switches are the same. Simply pull up on the hinged lower cover to reveal the terminals and switches. Note that the underside of the cover contains a reference to the quick setup parameters, and above the terminal strips there is a terminal and dip switch reference label for easier installation and commissioning. This picture is shown from the bottom of the drive. The green terminal blocks contain the I/O, relay, and RS-485 field bus terminals. The lower terminals are for the power input and motor output. Also shown are the grounding points. Note that the power, motor, and grounding point locations will vary on larger frame drives, but the green I/O terminals will be the same throughout the various frame sizes of the standard VACON 20. The VACON 20X and 20 cold plate drives use the same numbering on the I/O terminals, but are configured slightly differently. We'll look at both the standard VACON 20 as well as the 20X and 20 cold plate terminals. The VACON 20 series of drives are built with a standard of 6 digital inputs, 2 analog inputs, 1 analog output, 1 digital output, 2 relay outputs, and an RS-485 communications interface. Functionality can be increased by adding an additional option card for I/O or field bus expansion. Here we have a close-up of the I/O terminals. When using the I/O terminal strip as the reference location, the digital and analog inputs will control how the drive functions. We will briefly discuss the various I/O terminals and default functions. Starting with terminal number 1, this is a 10-volt DC reference voltage output with a maximum load of 10 milliamps. Terminal number 2 is analog input 1 and is a voltage-only input. Factory default function for this terminal is frequency reference, varying the output speed based on a 0 to 10 volt DC input, and is programmable for other functions. Terminal number 3 is ground for the I/O signals. Note that terminals number 3, 5, and 7 are internally connected by default. Terminal number 6 is a 24 volt DC 50 milliamp maximum output to be used for the digital inputs. Note that terminals 4 and 5 are located on the upper terminal block, so be sure to reference the manual or the attached label for correctly connecting all wiring to the terminal strips. Terminal number 7 is the digital input common and is defaulted as a ground. This can be changed by a jumper setting that we'll discuss later. Terminal numbers 8, 9, and 10 are digital inputs DI1, 2, and 3. When activated with 24 volts DC, DI1 is defaulted as run in the forward direction. DI2 is defaulted as run in the reverse direction, and DI3 is defaulted as a fault reset function. All digital inputs can be programmed for other functions, but this video will only discuss the factory default functions. Moving up to the next terminal strip, terminal number 4 is analog input 2 and is defaulted to 0 to 20 milliamps, but can be changed for a 0 to 10 volt DC input through a dip switch setting. Default function is PID actual value and frequency reference, and is programmable for other functions. Terminal number 5 is another I/O signal ground. Terminal number 13 is the digital output common. Terminal numbers 14, 15, and 16 are digital inputs DI4, 5, and 6.
When activated with 24 volts DC, DI4 is defaulted as preset speed 1, which is 10 Hz. DI5 is defaulted as preset speed 2, which is 15 Hz. And DI6 is defaulted as an external fault. If DI4 and DI5 are active together, preset speed 3, which is 20 Hz, is selected. Like the other digital inputs, these are also programmable for other functions. Terminal number 18 is an analog output and is defaulted for 0 to 20 milliamps, but that one can be changed for a 0 to 10 volt DC output. This is defaulted for output frequency, but can be programmed for other functions. Terminal number 20 is a digital output, which will supply a ground signal when active. The default setting will output a ground signal when the drive is in a ready state, but like the others, can be programmed for other functions. The next two terminals, number 22 and 23, are for relay 1. Terminal number 22 is a normally open contact, and terminal number 23 is the relay common. This relay is defaulted to be active or closed when the drive is in a run state, but can be programmed for other functions. Note that there is no normally closed contact for this relay. The next three terminals are for relay 2. The first terminal shown is not used, so no connection should be made to this terminal. Terminal number 26 is a normally open contact. Terminal number 25 is the relay common, and terminal number 24 is a normally closed contact. This relay is defaulted to be active when the drive is in a fault state, but can be programmed for other functions as well. The last two terminals are for the RS-485 field bus communications. Terminal A is the negative connection and terminal B is the positive connection. The VACON 20 series of drives have a built-in Modbus RTU field bus interface. Other communication protocols can be added through the use of various option cards. Moving on to the jumper and dip switches, here we have jumper J500. This jumper will define the type of digital input polarity to be used in the drive. With the jumper installed, which is the default configuration, all of the digital inputs will have a positive logic. This means that applying 24 volt DC to any digital input will activate it or turn it on. This is the most common configuration, but removing the jumper allows a negative logic for the digital inputs. This means that applying a ground signal to any digital input will activate it or turn it on. Starting from the left, the first dip switch shown will define how digital inputs 5 and 6 will function. With the switch in the up position, DI5 and 6 will function as normal digital inputs as discussed before, where DI5 is defaulted as preset speed 2 or 15 Hz, and DI6 is defaulted as an external fault. This is the factory default position for this switch. Flipping the switch down will allow digital input 5 to have an encoder input channel A up to 10 kHz, and digital input 6 to have an encoder input channel B up to 10 kHz, or a pulse train input up to 5 kHz. In addition to the dip switches, there will be parameter values that need to be configured when using a pulse train or encoder input. If using an encoder or pulse train input, be sure to select the encoder input position on the dip switch, as well as setting the parameter to change from a normal digital input to encoder or pulse train input. Otherwise, a fault 51 external fault could be displayed. The second dip switch defines the analog output signal for either a voltage or current output. The default is in the up position, which would be a 0 or 4 to 20 milliamp output. This picture shows the switch in the down position, which is a 0 to 10 volt DC output, and the type of signal I required for an analog meter needing a voltage signal for indicating the output frequency. The third dip switch defines the analog input 2 signal for either a voltage or current input. The default is in the up position, which would be a 0 or 4 to 20 milliamp input. This picture shows the switch in the down position, which is a 0 to 10 volt DC input, and the type of signal I required for my application. The fourth dip switch is used to add a 120 ohm termination resistor when using RS-485 communications. The default position is in the down position, which is off. If needed, the switch can be placed in the up position when the termination resistor is required. The VACON 20X and 20 cold plate drives look physically different from the standard VACON 20, but share the same keypad layout and terminal configurations. The first two pictures shown are the two frame sizes available for the 20X, which are MU2 and MU3. The third picture is a 20X MU3 with the top cover removed to show the internal configuration. The The fourth picture shows a 20 cold plate frame size MS3, which can seem to be identical to the inner power unit of the 20X MU3. The 20 cold plate is not supplied with an external housing or heatsink and is primarily used in OEM applications. The 20 cold plate is also available in frame size MS2, which is the same power unit used in the 20X MU2 drive, less the external housing and heatsink. Here we have line drawings of the various types of 20X configurations available. Again, the 20 cold plate is using the same power unit, which is shown in the bolder black drawings. In addition to the two frame sizes available for either the 20X or 20 cold plate, the smaller 20X, which will be the frame size MU2, or the 20 cold plate frame size MS2, is available in single phase or three-phase input. The overall configuration is slightly different between them, but they are very similar. Here we have a drawing of a three-phase power unit for a 20X frame size MU2 or a 20 cold plate frame size MS2. Again, the single phase and the MU3, MS3 versions will be very similar. Starting from the lower left, we have grounding points. Next, we have the motor terminals, then the power input terminals. In the top left corner are the optional brake resistor terminals. Upper right corner, we have 4 dip switches, which we'll discuss in a bit. Beside that are the terminals for the STO or safe torque off. Below that we have the input-output or I/O terminals, which we'll show in more detail. Under that are the LED indicators for power, run, fault, and ready. Finally, in the lower right corner are the terminals for the 2 onboard relays. Here's a close-up detail of the VACON 20X or 20 cold plate I/O and relay terminals. The terminal numbering is identical and has the same functionality as previously explained for the standard VACON 20. Refer to the user's or installation manual for detailed information regarding the terminal functions and connections, or download a copy of the manual from danfossdrives.com. Here are the 4 dip switches and their functionality. Starting with switch SW1, this switch will define the type of digital input polarity to be used in the drive. With a switch in the down or 0 position, which is the default configuration, all of the digital inputs will have a positive logic. This means that applying 24-volt DC to any digital input will activate it or turn it on. This is the most common configuration, but the switch can be moved to the up or 1 position to allow a negative logic for the digital inputs. This means that applying a ground signal to any digital input will activate it or turn it on. Switch SW2 is for analog input 1 or AI1, and SW3 is for analog input 2 or AI2. Either can be used as a 0 or 4 to 20 milliamp current or 0 to 10 volt DC voltage input. The default for SW2 or AI1 is voltage input, which would be the switches in the up or 1 position, and the default for SW3 or AI2 is current input, which switch would be down or in the 0 position. Switch SW4 is used to add a 120 ohm termination resistor when using RS-485 communications. The default position is in the down or 0 position, which is on. The switch can be placed in the up or 1 position if the termination resistor is not required. All of the VACON 20 series of drives share a common look and feel for the keypad. Here we will briefly talk about the various buttons and displayed information. Later in this video we will see an actual demonstration of navigation through the keypad. Pressing the lower right green button will initiate a motor start or run command when the drive is in keypad mode. Pressing the lower left red button will initiate a motor stop command. The default operation of this button allows it to provide a stop command regardless of the control place, meaning it will stop the motor if being controlled from the keypad, I/O terminals, or field bus. This can be changed to function only in keypad mode from the parameter menu if this is undesirable during remote operation. The OK button has various uses. It can be used to confirm a selection, such as when used to enter into a specific parameter to edit a value. It would also be used to alternate between the parameter number and parameter edit mode. The local remote button allows the drive to change where it will receive its commands. LOC or local would be keypad control, and RAM or remote would be controlled from either the I/O terminals or field bus. The operation of this button can be changed in the parameter menu, but the default operation is I/O terminal control. When pressing this button, it will toggle between I/O or keypad control. If the parameter is changed to field bus control, pressing the button will toggle between field bus or keypad control. If the parameter is changed to keypad, the button will no longer function and will be locked into keypad control until it's changed back to I/O or field bus control. The back reset button allows a backward step in the menu levels or allows a changed parameter to be canceled. It can also be used to reset a fault in the drive. Depending on the type of fault, it is possible that this button will not reset it. Some faults may not reset if the fault is still present, and some may require a power cycle to be cleared. The up and down arrow buttons allow scrolling through the parameter list, where up decreases and down increases the parameter number. When editing within a parameter, the up button will increase and the down button will decrease a value. It also allows the selection of the main menus shown on the left side of the display labeled Ref, Mon, Par, and Sys, and we'll discuss those items shortly. The left and right arrows allow individual digit selections when changing a value in a parameter. It can also allow you to navigate to the next parameter group up or down, for example going from V1.1 to V2.1. It can also be used to change the motor direction when in local or keypad control when in the ref menu. The left arrow would be forward and the right arrow would be reverse. The LCD display is used to indicate the status of the drive and how it is being controlled, viewing parameter menus and values, and monitoring of various drive input and output values. Note that you may need to have a paper or electronic copy of the user's manual for programming parameters, as there are no text explanations for the various parameters. The manuals can be downloaded from danfossdrives.com. On the left side of the display, there are 4 menu groups that can be entered. To change into a different menu group, press the back button until the pointer is flashing. While it's flashing, use the up or down arrow buttons to point to the menu group desired, then press the OK button. Ref is for the reference menu, and the display will show an R while the pointer is flashing. Entering into this menu allows displaying the keypad local reference and can be edited to the desired local reference value. The reference value displayed here will have no effect when using the I/O terminal or field bus control. Mon is for the monitoring menu, and the display will show an M while a pointer is flashing. Entering into this menu allows displaying actual values of measured signals, as well as the status of some control settings. These are read-only values and cannot be edited. Par is the parameter menu, and the display will show a P while the pointer is flashing. This menu allows you to browse and edit various parameter values. For the regular VACON 20 drives, only the quick setup parameter list is shown by default. By changing parameter P17.2 to a value of 0, many more advanced parameters will be visible. Sys is the system menu, and the display will show an S while the pointer is flashing. This menu allows you to view the fault submenu, field bus submenu, and system parameter submenu. When working within the monitoring, parameter, or system menus, any item beginning with a V is a read-only value and cannot be edited. Any item beginning with a P is a parameter that can be edited. Some parameters can only be modified when the drive is in a stop state. The user's or installation manual will indicate which parameters can only be edited while the drive is stopped. At the top of the display, there are 5 status indicators. If the pointer is displayed, the following information applies. Ready indicates that all conditions have been met in order for the drive to initiate a run command. Run indicates that the drive is currently running a motor. Stop indicates that the drive is currently not running a motor. Alarm indicates that an alarm condition has been met. The drive is still capable of running as long as it has not reached a fault level. Fault indicates that the drive has stopped due to a fault that has been tripped. This could be due to an external fault that has been programmed into a digital input, or an internal trip level has been met or exceeded. At the bottom of the display, there are 5 control indicators. If the pointer is displayed, the following information applies. FWD indicates that the motor is rotating in a forward direction. Rev indicates that the motor is rotating in a reverse direction. I/O indicates that the I/O terminals are the current control place. Keypad indicates that the keypad is the current control place. Or bus indicates that the field bus is the current control place. The quick setup parameters are found on the inside of the lower hinged cover on all frame sizes of the standard VACON 20 drives. These will be the only parameters accessible within the parameter menu unless the P17.2 parameter conceal value has been changed to a 0 to allow all parameters to be visible. Note that some of the default parameter settings are highlighted on this list. For example, P2.1 remote control place has the 0 highlighted to indicate that the I/O terminals are the default control place. This video will only discuss the quick setup parameters on the standard VACON 20 drive. Refer to the appropriate users or installation manual for the VACON 20 drive series you are working with for the complete parameter and value descriptions and an explanation of the various settings. Manuals can be downloaded from danfossdrives.com. Note that the menu structure and navigation will be the same for the VACON 20, 20X, or 20 cold plate, but there may be differences in the order the parameters are presented and may contain additional parameters for various functionality. I will briefly explain the various quick setup parameters for the VACON 20 drive in the video portion of this presentation. Here is a basic wiring diagram showing the default functions of the various inputs and outputs. This basic diagram is the same for the VACON 20, 20X, and 20 cold plate. I have an I/O simulator connected to the drive that I will be presenting in the video that is wired as shown. From this basic diagram, we see that terminals 1 and 3 are the analog input 1 reference voltage, and terminal 2 is the analog input 1 signal input for the speed reference as default. Terminal number 6 is the 24 volt DC used to activate the 6 digital inputs. Terminal numbers 8, 9, 10, 14, 15, and 16 are the digital inputs 1 through 6 with the default programming shown. Terminal number 5 is a ground, and terminal number 18 is the analog output, both which are connected to a current meter for indicating the output frequency. The standard VACON 20 drives contain 4 built-in application choices. The 4 choices are basic, pump drive, fan drive, or high torque drive. The application selection can only be made when the drive is in startup wizard mode, such as when a new drive is powered on for the first time, or when system parameter P4.2 is set to 1 to restore factory defaults. The startup wizard will be active after the drive has completed the restore defaults process. The first item found on the display is parameter P1.3. Pressing the OK button will allow you to change the motor nominal speed. Press OK, then parameter P1.4 will be displayed. Pressing the OK button will allow you to change the motor nominal current. Press OK, then parameter P17.1 will be displayed. This is the parameters to select the desired application. As per the chart, selecting 0 loads the basic application, 1 loads the pump drive application, 2 loads the fan drive application, and 3 loads the high torque drive application. Pressing OK to select the application is the final step of the startup wizard. Again, parameter P17.1 is only going to be available during the startup wizard. The chart shown shows the various changes to the default parameters depending on the application choice. This chart is also shown in the user's or installation manual for the VACON 20. This information does not apply to the VACON 20X or 20 cold plate. These drives contain multi-purpose application software from the factory with no additional application choices. They also do not offer a startup wizard or the parameter conceal option as in the standard VACON 20 drives, which means all parameters are available at any time.
First thing I'm going to do here is go into the system menu. I have the flashing pointer for the menus, so I'm going to scroll down to System, hit OK, and what I want to go to is parameter 4.2 in the system menu. Now I can navigate by hitting the right or left arrow to go up or down within certain menu groups. And that's what I did. So I came up to parameter group 4, and the first one in that group is 4.2. If I hit OK, I have a flashing 0. So if I change that to a 1, this is going to reset all parameters to factory defaults. The first parameter we see is parameter P1.3. That one is for motor nominal speed. When I go into that, we'll see the factory default of 1720 RPM. I can use my left and right arrow to change to the digit that I want it to change. So if I change this, if I wanted it to be 1745, I change it to that value and hit OK. The next item is parameter P1.4, which is the motor nominal current. So the default value for this drive is 1.7 amps. I can change that if I wanted to, and again, using the left or right arrows, I can change individual digits. I'll change this to 1.65. And the third parameter here is the application selection. Here's where I can decide, do I want basic, pump drive, fan drive, or high torque drive. So when I hit OK, 0 would be for basic, 1 is for pump drive, 2 is for fan drive, and 3 is for high torque drive. I'm going to keep it in basic, and I'm going to hit OK. And we'll continue on with the programming of various parameters. So again, our pointer is flashing for the menu selection. So just starting from the top here, we have our reference menu. This is going to display what our keypad reference is in hertz, and this is typically used in local or keypad control, although there is a parameter that will allow you to use this for referencing during another type of control if you wanted to do so. So at this point I can go in here and we see that right now it is set for 0 hertz. I can go in here and I can change that and I'm going to select 60 hertz as my nominal speed. So now that I've selected my motor nominal speed, I can hit the back button and I can select the monitoring menu. I hit OK, and our first value is V1.1. This is where it's valuable to have the manual, either an electronic or paper version, so that you can determine what these values actually stand for. So these again are monitoring values only, cannot be edited. If I go into this, it's telling me what my output frequency is at the moment, and I'm not giving it a run command, so it is at 0 hertz. I can't change anything with that. I hit OK and go back, and then I can scroll down to my next one. Here we have 1.2. This is our frequency reference based on the analog input that we have. That can be changed depending on where you set your analog inputs. 1.3 is motor speed in RPMs. And again, we're not running, so we have a 0 RPM. 1.4, motor current in amps. And 1.5, motor torque. 1.6, motor shaft power. 1.7 is our motor voltage. 1.8, DC link voltage. We can see we have a DC link voltage of 333 volts DC. 1.9 is our unit temperature. Right now it's showing approximately between 34 and 35 degrees Celsius for our drive temperature. And again, there's many other values that can be viewed here. Analog inputs, digital outputs, the status of our digital inputs, status of our pulse train or encoder inputs, PID values, and so on. The next menu is the parameter menu. This is where we can browse and edit parameters. So there are only a certain grouping of parameters because we are in the quick setup. We'll look at these. So P 1.1 is motor nominal voltage. This is based on the motor nameplate. 1.2, nominal frequency of the motor. 1.3 is our motor nominal speed, which we set during the startup wizard. 1.4 is our nominal current. Again, we set that during our quick setup. 1.5, motor cosine of phi. This is defaulted to 0.85. So again, you're going to be using the motor nameplate to determine what that value should be in there. 1.7 is our current limit in amps. 1.15 is torque boost, so 0 is off, 1 would be on if you wanted to use the torque boost function. P2.1 is our remote control place 1 selection. Right now it's set as a 0, indicating this is either going to be referenced from the I/O or keypad. If we change that, we could change that to field bus or keypad only. 2.2 is our start function. 0 would be for a ramping start, or I could change that to a 1 for a flying start. 2.3 is our stop function. 0 would be for a coast, or if we change that to a 1, it would be a ramped stop. P3.1 is our minimum frequency reference. So we could set that to a minimum speed of, say, 20 hertz if we wanted to do that. And that way the drive would never run below 20 hertz. P3.2 is our maximum frequency reference. And we have in there 60 hertz. P3.3 is our remote control place 1 frequency reference place. 3.4 is our preset speed 0, defaulted to 5 hertz. 3.5, preset speed 1, defaulted to 10 hertz. P3.6 is preset speed 2, 15 hertz default. 3.7 is our preset speed 3, which is 20 hertz. P4.2 is our acceleration time in seconds. The default is 3 seconds. We can change that to whatever value we'd like. P4.3 is our deceleration time in seconds. P6.1 is our analog input 1 signal range. 0 is a 0 to 100% signal, or we could change that to a 1, which would indicate a 20 to 100% signal range. I'm going to leave it as a 0. P6.5 is our analog input 2 signal range. Same thing applies. 0 is 0 to 100%, or a 1 would be 20 to 100% signal range. P14.1 is automatic reset. 0 is disabled, or if we change it to a 1, we would enable an automatic reset. P17.2 is our parameter conceal. Default value is 1, which will allow only viewing the quick setup parameters. We can change that to a 0, in which all parameters will be visible. I'm going to leave it as a 1 for this video. And then once we go to the next parameter, we loop back to the beginning again. The next menu is the system menu. The first value we see here is V1.1. Again, this is a value, read only. So V1.1 through 1.6 are specific to the application information, so application ID and version. So if we look into this, we'll see specific information that deals with the software. V1.7 is our system load. This is in a percentage. So we can see that we are right now at about 73% of system load. and this deals with the processor. V2.1 to P2.8 are all values or parameters specific to the internal Modbus communication capabilities of this drive. If a field bus option card was to be installed into this drive, then these parameters would change and it would automatically show the parameters associated with those cards. V3.1 is our energy counter, and that's measured in megawatts. V3.2 are the amount of days that this drive has been powered on, and here we can see that it's 3 days. V3.3 are the amount of hours that the drive has been powered on. In this case, it's 2. Once it hits 24, that will be added to the V3.2 power on days. V3.4 is the amount of days that the drive has been running. 3.5, the amount of hours that the drive has been running. V3.6 is a fault counter. This just adds up how many faults the drive has seen in its lifetime. P4.2, this is where we restore factory defaults like we did right at the beginning of the video here. So in this case, if we put a 1 in there, that would restore all defaults back to factory defaults. P4.3 is a password. The password in it right now is 0000, which indicates there is no password. But if I was to change any one of these digits to anything other than 0, this would put a passcode protection in that would lock out certain parameters from being edited. P4.4 is the backlight timeout function. So if we go into that, we see it's set for 5, and that 5 means 5 minutes. So we can set this for anything from 1 to 60, and that would be 1 to 60 minutes. If it was set to a 0, the backlight would be turned off. If it was set to 61 or higher, the backlight would always be on. P5.1 through P5.9 is the active fault menu. So any active faults that this drive would have in it would be displayed here in these parameters. If there was an active fault, we would also have a pointer showing to an alarm or fault here. If we go into this 5.1 is the most recent, and we show a 0 there, meaning there is no active fault at this point. So F5.2 through F5.9 would also show 0s and O's. F6.1 through F6.9 is the fault history menu. So we can go into that and we can see that we did have a fault tripped at some point in its history. And in this case, it was a fault 51. 51 is an external fault. We can get more information about that if we use the arrows. We can see the ID code for it, the day that it occurred, the hour that it occurred, and minutes. This ID number is important. If you need to call in for tech support, they may ask to know that ID number for the fault. And that takes care of the system menu. We'll move on now to running the drive. So at this point, I want to give the drive a run command. And we want to first do this in local or keypad mode. So the first thing I'm going to see is we are on I/O mode. So if I use the local remote button and push that, it puts me in the keypad mode. It also sets the menu to reference. Now I can change this value to wherever I want the drive to be running at. So if I wanted to go in here and change it to 40 hertz, say OK, and then I can hit the run button. So now you can see the run indicator is showing. We can look at some of the monitoring values. Go back down to the monitoring menu, and we can look at the motor speed in V1.3, and we're showing about 1200 RPM because we're running at 40 Hertz. We can look at the motor voltage in V1.7. Motor voltage is approximately 152 volts AC. So those are the items that you can monitor, and then of course you can look at any of these monitored values as you're using this drive. The other thing I want to show you, so I'm going to hit the stop button. Drive is now stopped. I'm going to go back to I/O. Again, we're ready, we're stopped, we're in the monitoring menu, we're on 1.7, which is motor voltage. I can open that up, and we can monitor the voltage to the motor. So if I turn digital input 1 on with my remote simulator for my I/O, we can see that we have an output voltage, and that can be varied based on my analog inputs. There's my maximum, and that's my minimum for my analog input 1. Turn digital input 1 off. We see that now the drive is in a stop state. I can turn digital input 2 on. We can see that the drive is showing a ramp down, and now it's ramping back up in the reverse direction because I have digital input 2 turned on. I've taken my analog inputs to the minimum. So in addition to using the analog inputs, we also can use the digital inputs for speed selection. So here I'm giving it a run command with no analog input reference at this point. If I turn digital input 4 on, that gives it a preset speed of 10 Hertz. Digital input 5 gives it a preset speed of 15 Hertz. And both 4 and 5 turned on gives it a preset speed of 20 Hertz. If I turn those off, we're back to analog input 1 and 2 controlling the output speed. In factory defaults, digital input 6 creates an external fault. As you can see now, we have the keypad flashing, the backlight flashes, telling us that we have some type of a fault, as well as the indicator for fault on the display. Factory defaults allows digital input 3 to reset that fault. The fault can also be reset through the keypad by hitting the back reset button. I hope this video on the basic setup for the VACON 20 drives has helped you. Again, be sure you have a copy of the manual during setup and commissioning available from danfossdrives.com for reference to the parameters and values. Remember that parameter P17.2 in the parameter menu can be set to 0 to enable all parameters to be visible to allow additional programming parameters.
Thank you for viewing. We hope this information has been helpful. Danfoss Drives can provide additional technical support, parts information, or repair services options by contacting us through one of the following methods. For immediate access to customer service or a technical support expert in North America, call 1-888-DANFOSS or 1-888-326-3677 or contact us through email. For technical support, the email address is drives.ts.na@danfoss.com. For customer service, the email address is drives.cs.na@danfoss.com. For after-sales service, the email address is drives.ts.service.na@danfoss.com. Additional information is also available on our website at www.danfossdrives.com. For contact information in areas outside of North America, please visit our global website at www.danfoss.com. Thanks again.